So, magandang araw. So, topic natin this week is about strength of materials, engineering materials, and pressure vessels. So, stress. Stress is the applied force divided by the antiform area over which the force is applied. So, design stress, used in determining the size of the member, also called the working stress or allowable stress. Yield stress, the maximum stress without causing deformation. Residual stress, stress left in a material due to the manufacturing processes. Fatigue stress occurs due to the cyclic application of stress. And thermal stress, stress that exists whenever temperature gradients are present in a material. So, elasticity, property of material which opposes any change in its shape and size due to external force and try to regain the same after the removal of external force. Plasticity, the quality of being plastically elongated. Next is Hooke's law. So, proposed by physicist Robert Hooke in 1676, sinasabi na yung stress is proportional sa strain. So, strain, ano ba yun? Strain. So, defined as change in length divided by original length. So, stiffness K describes the amount of force required to cause a unit deformation and is often referred to as the spring constant. So, ito yung formula. So, stiffness is equals to force over delta. Dilation, notation E. So, siya yung sum of the strains in the three coordinate system. So, ito yung formula. So, dilation, strain ng X, and strain plus strain ng Y, plus strain ng Z. Paano naman pag single coordinate system? So, ito yung formula niya. So, stress is modulus of elasticity times dilation coefficient all over 1 minus 2V. Yung V po nila is Poisson's ratio. So, Poisson's ratio, V, the ratio of lateral strain to longitudinal strain. And modulus of elasticity or Young's modulus, the unit measurement of a material's resistance to deform elastically when a stress is applied to it. It is also introduced by Thomas Young in 1807. It is also the slope of the stress-strain diagram in the linearly elastic region. So, next, modulus of rigidity, G, also called the shear modulus. So, formula niya is yan, modulus of rigidity is equals to E all over 2 plus 1V. 2 times 1 plus V. So, for the bulk modulus, describes the volume elasticity of the material. The formula, so K is equals to E all over 3 times 1 minus 2V. And the effective modulus, so M is equals to E times 1 minus V all over 1 minus V squared. So, ito naman next is the properties of commonly used materials. So, meron tayong, ito yung mga commonly used materials pag sa computation. So, yan. Meron tayong steel, aluminum, copper, iron, and cast iron or wrought iron. So, density ng steel is 0.284 in pounds, inches cube. And Poisson's ratio niya ng steel is 0.3. And coefficient thermal expansion alpha per degrees Fahrenheit. So, 6.5 to 7 times 10 raised to negative 6. Modulus of elasticity E in PSI, 30 times 10 raised to 6. Pag Modulus of rigidity naman, PSI din, ng steel is 11.5 to 12. Times 10 raised to 6. So, for aluminum, density niya is 0.098. Poisson's ratio, 0.33. Coefficient of thermal expansion is 12.5 times 10 raised to 6. Raised to negative 6. And modulus of elasticity ng aluminum is 10 times 10 raised to 6. And modulus of rigidity, 3.6 times 10 raised to 6. As for the copper naman, so density niya is 0.322. Poisson's ratio, 0.34. Thermal expansion coefficient, 9.1 times 10 raised to negative 6. Modulus of elasticity, 16 times 10 raised to 6. And modulus of rigidity, 6.7 times 10 raised to 6. Cast iron, density, 0.26. Poisson's ratio, 0.211. Coefficient thermal expansion, 6 times 10 raised to negative 6. Modulus of elasticity, 15 times 10 raised to 6. So, modulus of rigidity, 5.9 times 10 raised to 6. Wrought iron, density, 0.28. Poisson's ratio, same din, 0.28. Coefficient thermal expansion, 6.8 times 10 raised to negative 6. Modulus of elasticity, 28 times 10 raised to 6. Modulus of rigidity, 10 times 10 raised to 6. Next. So, simple and direct stresses. So, tensile stress, siya yung yung stress na nag-stretch sa material, nagpapahaba. So, yung formula niya is stress is equals to force over area. So, other niya is delta is equals to force times length, original length, all over area times modulus of elasticity. Compressive stress, siya naman yung ipapaikli or tumutulak paloob sa material. So, yung tensile stress is palayo yung force. So, nagko-cause to tend na pahabain yung material. Ito naman, kabaligtaran niya. Pinapaliit yung material or sinisiksik. So, same din. So, stress is equals to force over area. Delta force length all over area elasticity modulus. So, bearing stress, siya yung force over the projected area. So, stress, force over area pa din. Torsional stress, stress due to torque or twisting movement. So, ito naman yung sa material naman, yung twisting movement naman yung nagkakos sa stress. Solid circular shaft. So, ito nga pala yung formula niya muna. So, stress, torque, P over J. Pag solid circular shaft naman, so, stress, 16T over pi T3. So, diameter yon in T. And, or delta TL over JG. Where the torque, distance of farthest point from the neutral axis, J, polar movement of inertia, D, diameter of solid shaft, theta, torsional deflection in radians or degrees, L, length of shaft, ng G modulus of rigidity. Bending or flexural stress. So, may formula siya. So, ito, stress is equals to MC over I, or C is equals to I over C. Saan yung M natin is bending movement. C, distance of farthest fiber from the neutral axis. I, movement of inertia to the neutral axis. Letter Z, section modulus. So, thermostress. So, ito yung nag-cause dun sa temperature lang. So, formula niya, S is equals to E alpha delta T. So, yung alpha yung thermal expansion coefficient. So, E alpha delta T. Tapos, dito naman sa isa, change in length. Tapos, equals length alpha delta T. So, punching stress, formula niya. So, stress is equals to force over area. Pero dito yung area niya is for the flat surface. So, kailangan may diameter and thickness. So, pi distance times thickness. Shear stress. So, ito, meron tayong single shear na stress is equals to force over area. Saan yung area natin is pi over 4 diameter squared. So, pag sa double shear naman, so, dumoble lang yung area. Times 2 yung area. And beam slope and deflections. So, tignan nyo na lang din for save nyo. Screenshots nyo na lang kung ito yung mga beam slope niya. So, next. So, problem tayo. So, what is the maximum load? Can be on the column if the cross-sectional area is 144 square foot and the maximum stress exceed 200 psf. So, compressive stress. So, force over area. So, substitute direct. So, meron tayo 200 psf, 200 pounds feet squared. And it's equals to force all over 144 feet squared. Area. Okay. $200 equals to alpha x over 144. So, 28,800. 28,000 pounds all over 1,000 pounds kip. So, 28.8 kips yung final answer. Next, determine the average shearing stress of a 5 inches diameter rivet undergoes a shearing force of V is equals to 1,850 pounds. So, shearing stress, formula ng shearing stress, force over area na shearing. And area niya is pi over 4 diameter squared. So, input lang natin yung given. So, 1,850 pounds force. Pi over 4, 5 inches diameter squared. So, equals 94.22 psi, conversion psi. So cancellation of psi, so 1.032 times 1.32 kilograms centimeter squared all over 40.7 psi. So final answer natin is 6.615 kilograms centimeter squared. So check natin. So 1.032 94.22 times 1.032 over 14.7. So yun, 6.614. So tama po, 6.615 kilogram centimeter squared. So next. If the blade has an ultimate shearing strength of 5,245 kilograms centimeter squared, and the punch can exert a maximum force of 300 metric tons, determine the maximum thickness of metal plate in which a 6.5 centimeter diameter hole can be punched. So ito, stress SU is equals to force over area or force all over pi dt. So ito is punching stress. So ultimate stress, 5245 input kilogram centimeter squared is equals to 300 metric tons. Conversion in metric tons to kilograms, so 1,000 times 1,000 kilograms over 1 metric ton all over by 6.5 centimeter thickness. So input natin 5245 equals equals 300 times 1,000 over pi times 6.5 times alpha x. Shift solve. So 2.8 centimeter. Conversion natin, hinanap natin is in mm. So naka-centimeter pa siya. So 10 mm over 1 cm, cancellation, 28 mm. Final answer natin. So next. Compute the shear modulus for a steel with a Poisson's ratio of 0.24. So use standard modulus of elasticity for steel. So ito siya, yung nasa table kanina. So modulus elasticity ng steel is 30 times 10 raised to 6. So lagay natin si given. So modulus of rigidity is equals to elasticity modulus all over 2 times 1 plus Poisson's ratio. So input 30 times 10 raised to 6 psi all over 2 times 1 plus 0.24. So 30 times 10 raised to 6 all over 2 times 1 plus 0.24. So, yun. 12.1 times 10 raised to 6 psi times 1.01 megapascal conversion from 0.101325 megapascal over 14.7. Cancelled ang PSI. So, 83,381.34 megapascal. So, di pa siya tapos. Conversion lang. Nilipat lang natin. Kailangan natin is gigapascal. So, 83.4 gigapascal. So, next. The Poisson's ratio of a steel rod specimen of 15 inches diameter subjected to a tensile force F of 300 kips is given as 0.28. The modulus elasticity of the specimen is 3.4 times 10 raised to 7 psi. Determine the dilatation of the steel rod specimen. So, given natin 15 inches, force 300 kips, Poisson's ratio 0.28, and elasticity 3.4 times 10 raised to 7 psi. So, yung hinahanap natin, dilatation E. So, ito yung formula niya. So, dilatation E, 1 minus 2V all over E times force over area. So, yung area natin is pi over 4 D squared. So, input. Lagay lang natin yung mga values. So, 1 minus 2 times 0.28 all over 3.4 times 10 raised to 7 psi times force over area, force 300,000. So, 300 using 300 kips, and area pi over 4 over 15 diameter squared psi. So, yun. 1 minus 2 times 0.28 over 3.4 times 10 raised to 7 times force over area, 300,000 over pi over 4 15 squared. Yun. Final answer natin is 2.1967 times 10 raised to negative 5. So, next. So, pressure vessels. Siya yung mga containers for fluids under high pressure. So, meron types ng pressure vessels. May cylindrical shell pressure vessel and spherical pressure vessel. So, meron din siyang classifications na thin-walled and thick-walled na pressure vessel. So, yung thin-walled pressure vessel, siya yung mga vessel na may wall thickness na 0.05 or less na inner diameter ratio. So, ratio ng thickness over inner diameter. Kailangan less siya pa siya sa 0.05. So, kung may mapapansin kayo sa ibang references, so hindi lang 0.05. So, sa iba, 0.07 yung sa ibang reference. Considers that the stress distribution throughout its thickness can be assumed uniform or constant. So, stress is in thin wall cylinder. So, circumferential stress, also called as tangential stress, Hoof stress, or girth stress. Formula, S is equals to PD over 2T. Yan. So, longitudinal stress. So, stress is equals to PD all over 4T. So, yun. P for pressure, D for diameter, and 4T, letter T thickness. Okay. If joint efficiency, so note lang to if joint efficiency, itong notation N is given. So, for circumferential, so pressure times the diameter all over 2 thickness efficiency. Pag longitudinal, PD over 4 thickness N. Pag di naman given, so assume lagi na 100% yung efficient joint. Thin-walled spherical vessel. So, formula niya is PD40. So, pansin nyo kanina, 2T lang to. So, dito naman sa spherical vessel is 4 na yung thickness. So, kasi yung spherical vessel is twice as strong as the cylindrical vessel. So, next, thick-walled cylindrical vessel. So, refers to a vessel having a wall thickness to inner diameter ratio is more than 0.05. So, yan. Kailangan mas mataas 0.05 or sa ibang references is 0.07 na mas malaki pa doon. So, stresses, so axial stress or actual stress. So, axial stress is equals to piri-poro-roli. So, inner pressure tsaka inner radius na ng piri squared is equals to po outside pressure times inside radius squared all over outside radius squared minus inside radius squared. So, ito sa tangential tsaka radial stress. So, pares lang sila. Ang nagkaiba lang is yung sa tangential plus nag-add yung dalawa. And for the radial stress, minimum stress, nag-minus. So, tangential stress equals to inside pressure, inside radius squared minus outside pressure, outside radius squared all over outside radius squared minus inside radius squared plus inside pressure minus outside pressure times outside radius squared inside radius squared all over outside radius squared minus inside radius squared multiplied by 1 all over radius squared. So, sa radial stress, minimum stress, so same lang sila. Ang nagkaiba lang is itong dalawang operation. So, piri squared minus poro squared all over rho squared minus re squared minus p minus po times rho squared times re squared all over rho squared minus re squared. So, yun. Times 1 over radius squared. So, note lang, for tangential and radial stress, so use yung inner radius kung kinonsider nyo sa problem yung inner surface. And RO naman sa outer surface, stress is considered. So, problem, A thin-walled cylinder is 15 inches in diameter. The internal fluid is 150 psi. The wall thickness is 0.125. Find the induced stress in the cylinder wall. So given natin inner diameter 15 inches, inside pressure 150 psi, thickness 0.125 inches. So formula natin, tangential stress. So pressure diameter all over to thickness. So input, so 150 times 15 all over 2 times 0 point thickness. So yun, 9,000 psi tangential stress. Next. So yan, tingnan nyo muna screenshot. Okay. So next. With the present water interruptions prevailing in Metro Manila, you have been asked to design an upright cylindrical water tank 6 meters high, vented, and to be filled completely with water. Determine the minimum thickness of the water tank plate if the stress is limited to 40 megapascal. So, tangential stress pa din. So, pressure diameter all over 2T. So, P is equal to YH. So, 9.81 times 6 is 58.86 kilopascal. So, ito yung P is pressure yan. So, wala din sa given yung pressure. Kaya, yan, hinanap muna natin. And yan, direct input na. So, 40 is equals to 58.86 all over 1,000 times 6 times 1,000 all over 2T. So, yung 1,000 cancel na din. Kaya, direct na yan. 40 equals 58.86 times 6. Nilagay na rin natin for sure para baka all over 2T. So, yun. 4.41 4145. So, yung thickness natin is 4.41 millimeters. So, next. A thin hollow sphere radius of 10 inches and thickness of 0.1 inches is subjected to an internal pressure of 100 psi G. The maximum normal stress on an element of the sphere is what? So, tangential stress. Pero ito na is hollow sphere radius. Sphere vessel na to. So, yan na. Pressure diameter over 4 thickness. So, note lang natin, aware naman tayo, yung diameter is 2 times radius. So, lagay lang natin, input to 100 times 2 times 10 over 4.4 times 0.1. So, final answer natin is 5,000. Tangential stress niya is 5,000 PSI. Okay? So, next. A spherical shell of 1.8 meter of outside diameter and 1.725 meter inside diameter at a pressure of 10.4 megapascal. Compute the stress in the shell. Okay? So, meron tayo given outside diameter 1.8, inside diameter 1.725 meters. So, pressure 10.4 megapascal. So, walang sinabi kung anong uri ng pressure vessel ito. So, kailangan natin alamin. Then, wala rin ginigay na thickness. So, hanap pa natin yung thickness. So, yung inside yung outside diameter is equals to inside diameter plus 2t. So, lagay lang natin input, substitute. So, 1.8 is equals to 1.725 plus 2t. So, direct input. So, yung thickness natin is 0.0375 meters. So, gamit natin yung ratio para malaman natin yung thickness, kung thin wall ba siya or thick wall. So, thickness 0.0375 all over 1.725 is 0.02 daw. Ay, 0.02 nga. So, 0.02 is less than 0.05 kaya siya ay thin wall vessel. So, since alam natin, so tangential stress pressure is equals to pressure diameter all over 40. Tangential stress, okay. Pressure 10.4 is times 1.725 all over 4 times 0.0375 thickness. So 10.4 times 1.725 times 4 times 0.0375. So final answer natin is 119.6 megapascal. Okay? Okay. Next. So, a cylinder having an internal diameter of 20 inches and an external diameter of 36 inches is subjected to an internal pressure of 10,000 pounds square inches and external pressure of 2,000 pounds square inches. Determine the hoop stress at the inner and outer surface of the cylinder. Okay? So, given natin is inner diameter 20 inch, outside diameter 36 inch, inside pressure 10,000 psi, outside pressure 2000 psi. So, hinahanap natin tangential stress. So, yan kanina, of stress, nandun sa definition kanina of stress, so tangential stress. So, hinahanap inner and outer surface. So, yung formula natin is yung tangential stress. So, piriporo, Rory, na ano, so PD squared minus poro squared all over Rory squared minus P minus Po times Rory squared all over Rory squared. Rho minus Rho squared times 1 over R radius squared. So, since yung bigay dito is radius, so itong diameter natin is i-divide natin sa 2 for the inside radius and outside radius. So, input lang natin yan. Calcu. Store natin. So, 10 inches. Store A. Okay. 18. Store sa B. C is 10,000. Para din ng mahabang input. So, D, 2,000. Okay. So, gawin na natin yung piriporo. So, alpha C, piri. C times A squared, A squared. Minus poro. So, alpha B times yung po, letter D. Yan. Squared over Rory PA squared pala yun. Okay. So, P plus C minus po alpha T times Rory alpha B squared alpha A squared. Rory rho minus 3, so alpha B minus alpha A squared times 1 over R squared. Inside radius niya is 10 alpha A squared. So, yan. CA squared TB squared over B minus A. So, may mali tayong input doon. B minus A. So, may mali ako sa input kanina. So, ano yun lang. So, okay. May mali pa ako sa input. So, may type error lang. Siguro may mali ako sa input. So, basta yun na yung ano, ito na yung ano niya, computation niya. So, final answer talaga niyan is 13,142.86 PSI. So, yun lang naman. So, thank you. So, pagpasensya na rin yung ano, yung sa nangyari nga, yung na-delay ako sa biyahe. Okay? So, yun lang. Thank you.